In this video, we're going to take raw data like this and organize it using tally tables into frequency data. So here I have the raw data below shows the marks of students in a math exam. We want to use a tally table to organize the raw data. Now, when looking at the raw data like this, what I'm interested in is what is the highest and what is the lowest. So I'm looking through to see what is the highest and what is the lowest. I have 10 here so far as the highest, and I'm seeing 0 so far as the lowest. So having done a brief analysis of the data, I could determine that 10 is the highest mark and 0 is the lowest mark. So under my column for marks, and the variable that we'll use for marks is x, I'm going to start with 0 and go all the way down to 10. And now I'm going to do the tally. So we're going to start going through the raw data, and we're going to start with the first one, which is the 1. We're going to cross out like this. And where we have 1, we're going to put a stroke. Then we're going to cross out the 3 like this. Where we have 3, we're going to put a stroke. We have another 3 like this. Put another stroke by 3 like this. Then we have 5. By the 5, put a stroke. 10. Put a stroke here. 5 again. Put a stroke. We're going to have 9. Put a stroke like this. 7. Stroke here. 3. We're going to put a stroke here by 3. 4. Stroke. 6. And we keep going on like that until we reach the end. Now, as we cross off the 3 here, we already have 4 strokes on the 3. So instead of putting a 5th stroke, what we're going to do is just cross it like this. So 4 strokes like this and then crossing it like that would represent 5. Now that we analyze the raw data starting from the first digit to the last digit, and we have our tally, now it's time to write down the frequencies. So this frequency here will be 1. This will represent 5. For 2, we have 0. So for 3, this is 5, 4 strokes, and then across through like that, that's 5. So that's 5 and 4 strokes, that's 9. This will be 4. This will be 5. This will be 2. This will be 5 plus 5, which is 10. This will be 2. This will be 5. And this will be 3. And there you have it. We have organized our raw data into frequency data. So now we can clearly see we have 1 student got 0 marks, 5 student got 1, no student got 2 marks, 9 student got 3 marks, 4 students got 4 marks, 5 students got 5 marks, and so on. So having your data organized in this form, it's much easier to read and understand than having it in raw form like this. So let's look at something. I have my marks, and my variable for marks is x. So these are all my variables here from 0 to 10. So let's just say we have some raw data to organize, and the variables are just too much. What we could do, we could group the variables into what we call a class interval. So let's just say I have a class interval from 11 to 15. This 11 here is what we call the lower class limit, and this 15 will be called the upper class limit. All right, so I've labeled it. Lower class limit is 11, the upper class limit is the 15. Now you may be thinking, this class interval holds variables between 11 and 15. And you're right. But it also contains variables a little before 11 and a little after 15. So now let's look at the lower class boundary and the upper class boundary. So I'll just write over my class interval 11 to 15. And my lower class boundary will be 0.5 less than my lower class limit. So 0.5 less than 11 is 10.5. And this will be my lower class boundary. So far, this means that this class interval will hold variables from 10.5 and up. Obviously, it's not unlimited because we also have a upper class limit, which means we have an upper class boundary as well. But 10.5 would fall into this class interval, 10.6 would fall into this class interval as you go up. So now looking at the upper class limit, the upper class boundary would be 0.5 more than the upper class limit. So 0.5 more than 15 would be 15.5. So I'm just going to put the upper class boundary here, 15.5. Now, unlike the lower class boundary where 10.5 would fall within this class interval, 15.5 would not fall within this class interval. Up to 15.499999 reoccurring, that is what will fall within this class interval. But this is the boundary. So this class interval, the variables cannot cross 15.5. So it goes up to 15.4999 reoccurring like that, but it doesn't go to 15.5. 15.5 would be in the next class interval. So 11 to 15. Our next class interval would be 16 to 20. So this will be lower class limit and this will be upper class limit. But the lower class boundary for the 16 would be 15.5. And therefore 15.5 would fall within this class interval. And of course the upper class boundary for this class interval will be 20.5. So I just brought the class intervals on top here so we can look at the boundaries. So we have 16 as the lower class limit. So 15.5, which is 0.5 less than 16, will be the lower class boundary. We have 20 as the upper class limit. So 0.5 more, which is 20.5, would be the upper class boundary. So here you can see that the upper class boundary of this class interval is the lower class boundary of the next class interval. And that's why 15.5 will fall within this class interval and not this one. Now, when talking about class intervals, another point of interest is the class width. Now, the class width is equal to the upper class boundary take away the lower class boundary. Now, you cannot use the upper class limit take away the lower class limit. It must be the boundaries. All right, so we have class width is equal to the upper class boundary take away the lower class boundary. Now, we can use some abbreviations. All right, so I have class width is equal to, and instead of writing out the whole word upper class boundary, you could just say UCB. So that'll be upper class boundary. Take away LCB, and this will be lower class boundary. So if I were to look at the class width for the class interval 16 to 20, all right, so we have for the class interval 16 to 20, the class width is equal to, we're going to have the upper class boundary, which is 20.5. Take away lower class boundary, which is 15.5. All right, so if you go on a calculator, let's put in 20.5, take away 15.5, and we get 5. So our class width is equal to 5. So I'm just going to come here and put equal to 5. Now, some students think that they can just subtract the lower class limit from the upper class limit and get the class width. Now, let's see what will happen when we say 20 subtract 16. So if you say 20 subtract 16, notice the answer is 4 and not 5. So the class width is 5. But if you take away the lower class limit from the upper class limit, you will get 4. So you see two different answers. So the right way to do it is the upper class boundary take away the lower class boundary to get the class width. Now, another point of interest when dealing with class intervals is the midpoint of the class interval. So let's take our class interval of 11 to 15, and let's find the midpoint of this class interval 11 to 15. So here we have the midpoint of the class interval 11 to 15. Now we can do this in two ways. We could add the upper class limit and the lower class limit and divide it by 2. Or we could add the upper class boundary and the lower class boundary and divide it by 2. You'll get the same answer either way. So I could say 15 plus 11 divided by 2, put is equal to. All right, so let's see. 15 plus 11 plus equal, we get 26, and then divide that by 2, and we get 13. So our midpoint for the class interval 11 to 15 is 13. Now let's put or. We could say the upper class boundary, which would be 15.5, which is 0.5 more than the upper class limit, plus the lower class boundary, which would be 0.5 less than the lower class limit, so that'd be 10.5. Right, 0.5 less than 11, 10.5. And now we divide that by 2. Let's see what we get. So I'm going to put in 15.5 plus 10.5 press equal, and then divide by 2. And we can see we still get 13. So for the midpoint, it doesn't matter whether I use the class limits or the class boundaries to derive the midpoint. But for the class width, you must use the upper class and the lower class boundary. You cannot use the class limits. All right, so moving on to this question, we have the raw data below shows the marks of students in a math exam. We're going to use the tally table to organize the raw data. Now, I'm going to go through my raw data and see what's the highest and what's the lowest. So I'm seeing 100 here so far. Going through. I'm seeing 1, so that looks like the lowest. So do I see 0? No. So 1 is the lowest. Do I see anything above 100? No. So 100 is the highest. Now, that's a lot of variables from 1 to 100. I'm not going to come here and list out 1 to 100. That'll be too much. So that's why I'm going to use class intervals to group the variables. So I can look at this and say, well, since I don't have 0, I could start at 1 and go from 1 to 10 as my first class interval. So I'll have 1 to 10. And then following that, we'll have 11 to 20 with that same pattern. And then 21 to 30. Now remember, we had to go up to 100. So 31 to 40. Then 41 to 50. 51 to 60. 61 to 70. 71 to 80. Then we're going to have 81 to 90. And then 91 to 100. So these are my class intervals. Now I'll do the tally. So when I cross off 90, that will fall within the class interval 81 to 90. Because remember, this going up to 90.5. So I'll put a stroke here. Then 95, that will fall in the class interval 91 to 100. Well, 100 will fall within the class interval 91 to 100. 85 will fall in the class interval 81 to 90. 52, that'll be between 51 and 60. 43, that'll be between 41 and 50. 35, that'll be between 31 and 40. 11, that'll be between 11 and 20. 5, that will fall between 1 and 10. 1, that will fall between 1 and 10 as well. 56, that will fall between 51 and 60. And I think again the point here. 82, that falls between 81 and 90. So I'm just going to do the rest quickly. All right, so now that I have my tally completed, now to write down the frequencies. So this will be 5, this will be 4, this will be 0, This will be 3. This will be 3 again. This is 5 and 1 is 6. This is 1. This is 3. This is 4. And this is 5 and 3, which is 8. And this is how we use class intervals to group our variables, to do our tally table, to organize our raw data. So now, looking at this question, the raw data below shows the heights of students in centimeters for a class. We're going to use the tally table to organize the raw data. Now you can see we have some decimal points here. Now let's look at what is our highest and what is our lowest. So for our highest, I'm seeing 70.4. Anything higher than that? No. And for my lowest, I'm seeing 140.9. So what I could do, I could group these things into some class intervals. Now, seeing that 140.9 is my lowest, I could actually start with 141 as my lower class limit for my first class interval. So that would look like this: 141 to 150. So now remember, this class interval will take values from 0.5 less than the lower class limit, which would be 140.5. So this 140.9 would fall within this class interval 141 to 150. So now continuing with this pattern, we're going to have 151 to 160. Then we're going to have 161 to 170. And seeing that my highest value is 170.1, I don't need to go beyond this class interval because this would take up to 170.5, which is 0.5 more than the upper class limit. So now let's do the tally table. So 160.5, we come here. This class interval 151 to 160 will take up to 160.4999. So it would not come into this class interval, but it will go into the one 161 to 170, because this would start at 0.5 less than 161, which is 160.5. So I'm going to put the stroke here, and not in this class interval, because this ends at 160.4999. This starts at 160.5. Okay, so what I have here is the lower class and the upper class boundaries for the different class intervals. So you can clearly see for the class interval 161 to 170, the lower class boundary is 160.5. So this 160.5 would fall within this class interval. And of course, this class interval ends at 160.5, but is actually 160.4999. So now 163.9, that will fall within this class interval here, 161 to 170. Then 155.4, that will fall within here, 151 to 160. 143.2, that falls here. 170.4. So here we go up to 170, but notice the upper class boundary is 170.5, which will contain this 170.4. So I'm going to put the stroke here. Then we have 155.5, that comes here. 152.6, that comes here. 156.2, that still comes here. 170.3, again, this takes up to 170.5. So, well, actually 170.499. So it still comes here. Then we have 156.8. So that comes here. So upper stroke like that for 5. 165.7. That will come here. So upper stroke here for 5. 140.9. So again, we're looking at this class interval. This starts at 141, but look at the boundary. 140.5. So 140.9 would fall within this class interval because the lower class boundary is 140.5. So I'll put a stroke here. Then we come to 157.1. So that's here. 148.5. That's here. 168.2. That'll be here. 170.1. Again, that falls within this class interval because we go up to 170.499. So that comes here. Then we have 146.3. That comes here. And then 149.4. So that'll come here and make it 5. So now to write down our frequency, we're going to have 5 here. 5 and 1 is 6. And 5 and 2 is 7. And that will bring us to the end of this video.